Welcome to The Explainer. Today, we're going to crack the code on digital security. You rely on this system every single second you're online to keep your life private. But how does it actually work?
Well, it all starts with this tiny, super familiar symbol. But that little padlock, it's not just for show. It's really the tip of a massive iceberg, representing this incredibly powerful idea that protects your passwords, your messages, and your bank details every single day.
All right, to really get this, we've got to start with the simplest concept out there. Just imagine a digital lockbox that uses only one key to lock it, and that same key to unlock it. This is what we call symmetric encryption. And the name, well, it kind of says it all. The exact same secret key that scrambles your data into total gibberish is also used to unscramble it back into something you can read. It's simple, it's direct, and you know what? For the most part, it works great. But there's always a trade-off, right? Symmetric encryption is an absolute speed demon. It's incredibly fast, super efficient, and just perfect for encrypting huge amounts of data. But it has one giant critical weakness. How in the world do you get that single key to the other person securely?
This weakness is so fundamental it actually has a name: the sharing dilemma. And honestly, this is the problem that nearly stopped secure communication on the internet before it could even get started.
Okay, so think about this for a second. To unlock your secret message, your friend needs the key, but you have to send it to them over the internet, which is the exact same channel you're trying to keep secure in the first place. If there's a hacker listening in on that connection, sending the key is basically like writing your password on a postcard and dropping it in the mail. The second they grab that key, poof, your entire secure system is completely broken. That's the fatal flaw. So, to solve this seemingly impossible problem, cryptographers came up with this incredibly clever, almost magical solution. They thought, what if, instead of trying to protect one key, we used two? And this is asymmetric encryption. It works with a matched pair of keys. Now, one is the public key. You can shout this from the rooftops, post it on a billboard, give it to literally everyone. This key can only be used to lock data. And then you have the private key. This one, you guard it with your life, because it's the only thing in the world that can unlock data that was locked by its public partner.
Think of it like a personal mailbox that has an open mail slot. Anyone in the world can use your public key, that's the open slot, to drop a message inside, but only you have the unique private key that's needed to actually open the box and read what's inside. And just like that, the whole key sharing problem, it's gone.
So now we've got two very different tools in our toolkit. On one hand, you've got symmetric encryption, which is lightning fast, but, super risky to set up. And on the other, you have asymmetric, which is perfectly safe to set up, but it's so much slower. It's way too slow to encrypt all of your web traffic, for example.
Which brings us all the way back to our little padlock. Faced with these two choices, one is fast but flawed, the other is secure but slow, what does your browser actually do to keep you safe?
And here's the truly brilliant part. It doesn't choose. It uses both of them in this perfect partnership where the strengths of one completely cancel out the weaknesses of the other.
This amazing combination is what we call the hybrid approach. And let me tell you, it's the absolute bedrock of modern internet security, happening millions of times a second all across the entire globe.
So here's the play-by-play. First, your browser and the website use that slow but super secure asymmetric method for just one single task, to safely agree on a brand new, one-time use symmetric key. Once that session key is safely delivered, they both just toss the slow method aside and switch to the super fast symmetric encryption for the rest of the conversation. It's kind of like using a secure armored truck just once to safely deliver a pair of simple, fast walkie-talkies for the real conversation.
And when you see them side by side like this, it's obvious they're perfect opposites, right? One is built for the raw speed you need to handle tons of data. The other is built for the rock-solid security needed to exchange keys and establish trust. Together, they form a complete solution. Okay, so why does any of this matter to you? Well, because you are interacting with both of these systems constantly, all day long, probably without even realizing it. They protect you in so many more ways than just browsing the web. Anytime you need to protect a huge amount of data, and do it quickly, symmetric encryption is the undisputed champion. Those end-to-end encrypted messages you send, a locked folder with sensitive files, your entire hard drive being encrypted, all of that is thanks to fast, efficient, symmetric ciphers. But when the goal isn't speed, but trust and proving who you are, asymmetric encryption is absolutely essential.
When you digitally sign a contract, you're using your private key to create a unique, verifiable signature. It's mathematical proof that it was you and that the document hasn't been touched since you signed it. So I think the ultimate takeaway here is that our secure digital world isn't built on just one single breakthrough. It's built on the really elegant teamwork between two very different ideas. This hybrid model, it gives us the best of both worlds, the unbreakable trust of asymmetric keys and the raw speed of symmetric ones. That little padlock icon really represents a brilliant solution to a super complex problem. It's a testament to human ingenuity. But it also leaves us with a huge question for the future. This entire system of security, it relies on math problems that are just too hard for our current computers to solve. So what happens when a new kind of computer comes along that finds those problems easy? Well, that's the challenge for the next generation of cryptographers.